Hello. A little late right now. We doing this one. Given string S. This is that. We live. Oh, trailing well. Mm. Okay. A times B into N1. So it would be you split to 2. Is there a better way to do that? If not, she's going to do DP. Now what they're looking for? 6. Select exactly one integer from each row. Return the minimum. It's very similar to the one we have like 2 weeks ago. If all of them minimum. When you choose this bit, let me see the constraint. Okay. Right, so when you choose this, bit, flipped it on. You make it without. So when you do this for so when you do this, so when you check the 30th bit, okay. So what you're trying to say is, what you're trying to say is, X this 3, 5, 7. Okay. K distinct integer. K distinct appear at least m times. Okay, contain exactly this. Appear at least m times. So the minimum frequency. Minimum frequency? Not entirely sure. Okay, what we doing? At least m times, so we can do something as okay. So from this spot, we binary search on the bound where, for example, this one, and it will contain contain at least k, and then we binary search on the furthest. This is hard. The least frequent. Well, we can do most frequent. Least frequent. What is K? Oh, it's got it cooked. Let's get it cooked. At least m times. Can we do probability here? Not sure. Because with probability, we can definitely do something about it. So exactly k integer. Not sure on this. Yeah, it is binary searchable. It is binary searchable. The subarray contains exactly k. And within it, exactly m times. We do square root on this. How is it 100 already, dude? Do square root? Square root of what? Square root. I think that's tough. Because, when we do this kind of subarray, and we want it to be k distinct, right? So there's a window where it's k distinct. Then when you move to this window, for example, it's k plus 1. So what we can do is at this index, this is safe. So, but we have to maintain the end thing as well, which is somewhere the safe array is in this range. And you take this minus whatever that safe is, and that's it. Did it? Um, I don't know. I think we can do something as n locks where n, but I'm not sure about this constraint. It doesn't look. It doesn't look right. It doesn't look right for constraint to be correct. Um. Oh, okay. So we could do sliding window. Okay, that is safe. That's interesting. So we can do something as a sliding window of k distinct. Okay, so we know in this window it is k distinct, and we are going to have a vector to keep it at least m. How we do that? Just n, meaning from here to here, correct? Okay, so for example, when you have a number, what you can say is, okay, in this range and backward, I am safe. Is that true? Yeah, in this range backward, I'm safe. So potentially, we will count how many equal to k. That looks correct. True. I mean, it looks correct. Okay, I haven't really fixed this guy. Okay. Let's see, what do we fixed? I swear to God I did fix it, but for some reason. Going back again. Okay. No, 64G. Okay. Hopefully we don't need that. Okay. What else do we need? So when we just need these two. I think it's safe to. So you're saying it is 1. That's is equal to V. And max 0. CNT is V. It is valid, right? It's valid. Yeah. Okay. Then we can do something else. Um, okay. We work on this? Sure we can. Gotta modify this a bit. What do we do? We sliding window. Nice listening. Yeah, we can do this. Now, now what do we do? Be honest. We do MP of AI vector position. We do that. Yeah. We can. We can do a while MP dot size is greater than M or something like that. Well, MP dot size is like greater than M. No, it's greater than K actually. We shipped the window. What else? Okay. You can erase Y. Yeah, so that's safe, right? Okay, then what? Push back R, then if initial P dot size is actually greater than or equal to M, initial latest equal to P of P dot size where M initial second 0, otherwise P of P dot size minus M minus 1 plus 1. Okay. From second latest to latest 1. Root dot release range from LR if it dot mx think that's it. 2, 3. Oof. Okay, that's nice. That's really nice. Very nice contest in a while. I haven't really done this good. For sure, I haven't done this good. Damn, that feels good. Feels really good. Okay, we can go over the contest right now. So Q1 is you just remove the back, the trailing vowel. I believe it's fairly easy. Yeah, you can just do it like this. Okay. For Q2, you're given an integer n. In one operation, you can split x into a and B such that they are greater than or equal to 1, 2 positive. They plus together equal to x, and then the cost is A times B. What does that mean? So you can think about it in terms of this is n, right? I represent this line as n, then you can split it into A, then B, and the cost is A times B, and you want this A to split again to some A delta something. Then you split them until they become all one, right? So for example, like number 5, you can split into 2 and 3. Then the cost is 6. Then you split this one into 1 and 1. Then you plus 1, so it's going to be 7. You split it into 1 and 2, for example. Then it's going to be 1 times 2, which is 2, and then plus 7 is 9. And split this one again. That will become 10 or 1, 1, right? The next step, yeah, so that's it. Uh, this is not a hard problem in my opinion, but the the thing is, it is the second question, so I expect something more standard and easier topic. Yeah. But this turned out I did DP. I'm not sure if there's another way. So I just ran a DP. I run a DP as in like dpn is equal to dpa plus dpb plus a times b, right? dpa and dpb is the cost to split a into all one and the cost to split b into all one. Yeah. Then you plus a times b, which is the cost now. And you're just going to be initial I is equal to 2, I is less than or equal to n. Then you just build it up, right? dpi is equal to std min dpi dpa plus dpb a times b, where a plus b is equal to n. So that's just another loop, which I did right here. Then I just did a pre-process it once, and the answer is oh 1. That's it. Which is ends where for the pre-processing. Yeah. For Q3, Q3 is very similar to. It's really similar to the one I believe 3 weeks ago about the binary search on the bit as well. So what does this problem say? You have a grid. And you're trying to pick a number from each row such that the minimum or y, for example, z, k, y, z, k is minimum as possible. That's the whole thing. It's a short statement. Pretty tricky if you're not experienced. But yeah, you're just binary search on a for example, you have this kind of bit, right? You binary search on this bit, and I'm saying like if I have this bit at 0, like for example, the previous is like 110. Now you choose this bit at 0, because the thing about this is you greedy as early as possible to not have it as a 1. We don't care about the other stuff, right? We just care, can we make this one a 0? Because if we make this one a 1, it doesn't really matter what the bit later on, because 0 is always smaller than this one. Yeah, we are checking, can we make this one as a 0. And if we can, we don't have to turn it on. And yeah, that's just it. Your binary search on each bit, you check if this bit, if the prefix of B can be made without turning this bit on. And you go over each character, each number in the grid, each row actually, and you check if, for example, X and the prefix of X, the prefix of B of X. So for example, X has this at like B prefix. I'm gonna OR it with this one, OR it, and see if it doesn't turn this 0 on, and I'm good, right? Yeah, that's it. Um, that's all for Q3. For Q4, Q4 is a hard, like really hard. Because I can tell you now that this question was from a div to E, no, div to G, a div to G of code forces called three occurrences. The reason I remember this was I watched a video of tourists solving this one, and it actually took me a while to understand the solution of them. I spent a lot of time learning and analyze the solution of this. That's why I was able to solve it fast. So in this question, right, is 1500 rated? And in this question, you're basically trying to find the count of subarray that every number in it occur exactly 3 times. Let's that sink in. And this one is harder. I'm pretty sure. I am pretty sure this one is harder. It's not 3 times, it's m times, and you have to exactly k distinct. So, okay, this is hard. I cannot really go over this because this is I kind of did it like a big brain move on sec tree. So basically, when I have this number, right, I'm going to check what is the latest position where there are m occurrences of this. I'm going to say this. Example, this one. I'm going to add 1 to every prefix of this. Okay. Let's slow down a bit. Add 1 to every prefix of this. This is related to lazy segment tree. If you don't familiar, it is, you cannot really follow me on this one. For example, I have k as like 2, for example, and I'm saying that at this spot, um, any subarray later on this one will guarantee to have this one as an element with greater than or equal to m occurrences. Now we need k, right? We need 2. So for example, when I have this one as well, um, I'm going to say this is the latest position where every subarray before this is going to be valid. And I'm going to add 1 onto this as well. So when we look at the plus, the delta of this is going to be 1, this is going to be 2, this is going to be 2. And what does this mean is this is this is 2, meaning there are 2 occurrences of it, and I'm actually curious, do I need... Oh, okay, maybe I do. Oh, we can ignore that. So first we go into sliding window, this thing, to for each R, the leftmost, where the number of distinct is less than or equal to k, right? And then when I do, for example, this is L, and this is 2, this 2 means that every number in this range from L to R, how many has greater than or equal to m frequency, and I'm saying that is 2, and so this position is valid. If the L is right here, then this position is valid. So for this R, there are 2 subarray if L was here, but 1 if L was here. So yeah, that's it. I cannot really explain this question because it's not a simple one for a lot of people. It's kind of advanced. So yeah, what do we do here is we create a map, frequency map, then a post. Then this is a lazy secretary that we are going to put it later on. Now we have a R and a L pointer, so I'm going to increment the map right here. And then for a vector, the thing is I'm trying to keep track of the latest, like before where to +1, right? On the interval. If this size is greater than or equal to m, meaning that some position right here for this R, I'm telling you for this R, some position right here, I will add 1. But I do not add 1 to the entire prefix because when you are right here and that position is like right here, P, you cannot add 1 to the entire one because, for example, when this number was like up here right here and you add 1 to the entire prefix here, it turns out to be 2 right here instead of like full of 1, right? So yeah, it's just a little po- um little tricky that you only add this subarray 1. Yeah, that's why I have the latest and second latest, which is just the pointer before this latest. The update 1 on it. Then when I sliding with this window, I don't really have to do anything except for keeping the size of the map restricted. And then when I have this L, which is the latest index, is latest index where there are distinct, right? True. I'm going to if we only add to the answer if the count is k. We are going to have a set tree of counting the count of the maximum. That's what we are doing in the info section. We have the mx as 0 for initialize, and the count is 1 for initializing as well. For this set tree is counting the number of maximum that appear on a subarray, right? Yeah, and that's it actually. I am really surprised that I got this one really like one shotted because I am not confident about the runtime or leak code. It is a login. Okay. Yeah, I think I will end the video here. Um, yeah, I think I did really well. Ignore the cheater though. Okay, have a good day. Thank you for your time. See you guys next time.